Section 2.6 explores how the periodic table is arranged and the different areas are classified. If you have not already done so, you'll need to memorize the names and symbols of the elements on the Concepts to Memorize sheet found under Course Details on Canvas. Be able to recall the difference between rows and periods, and use the periodic table to classify elements in a variety of ways. Let's begin. Elements with similar chemical characteristics have been grouped together in various ways over time. The periodic table is the result of many years of refining this grouping. On the modern periodic table, elements are arranged horizontally in order of increasing atomic number and grouped vertically by similar chemical properties. Initially, elements were ordered by atomic mass, but after the publication of Dalton's hypothesis, many scientists worked to determine relative atomic masses of the known elements. Two scientists, Dmitri Mendeleev and Lothar Meyer, combined the known atomic masses and the known elemental characteristics to produce a periodic table. However, Mendeleev used his periodic table to predict the existence and properties of yet-to-be-discovered elements, as indicated by the red boxes in the image. Mendeleev chose to place the elements iodine and tellurium in opposite order than their atomic masses would suggest, placing them with elements of similar properties. His assumption that their masses were incorrectly determined proved to be correct. There are two other pairs of elements that are out of place according to atomic mass. Can you find them? Pause the video to look. The first pair consists of argon and potassium. The second pair is cobalt and nickel. When the periodic table was developed, noble gases hadn't yet been discovered. Noble gases are inert, meaning that they do not typically combine with other elements to make compounds. Helium was discovered first because it made emission lines in sunlight that could not be attributed to any other element. The other noble gases were discovered when scientists realized the density of air differed from their calculations. Noble gases were the cause. While they are not very reactive, the noble gases do give pretty emission spectra when electricity is applied to them, which is how we get neon signs. Let's turn our attention to naming the parts of the periodic table. Elements in a row are in the same period. The modern periodic table contains 7 periods. Elements in the same column have the same chemical properties. For this reason, we say that they are members of the same group or family because they behave in a similar fashion. Groups have been numbered according to an older system using group 1 through 8 plus an A or B designation, as shown here, but the modern group numbering system is simply 1 through 18 from left to right. Be able to use either number system to find an element. Certain groups have names to describe them according to their chemical properties. Group 1 is composed of the alkali metals, including sodium, lithium, and potassium. Group 2 contains the alkaline earth metals, including calcium, magnesium, and strontium. Group 11 contains the coinage metals you're familiar with, copper, silver, and gold. Group 17 contains the halogens, such as chlorine, bromine, and iodine, while Group 18 contains the noble gases we saw on an earlier slide. Let's pause here to see how well you can apply this information. Which element begins the 4th period of the periodic table? Which element ends it? How many elements are in that period? Potassium begins period 4. Krypton ends period 4. There are 18 elements in period 4. Here's another example to work through. Select the period and group where each of the following elements is located. It may be helpful to download the IUPAC periodic table provided in Canvas with this lesson. Select the period and group where each of the following elements is located: neon, rubidium, tungsten, and francium. Neon is in period 2, group 18. Rubidium is in period 2, group 1. Tungsten is in period 6, group 6. and francium is in period 7, group 1. With that information, which two elements would you expect to have similar chemical properties? Rubidium and francium will have similar chemical properties because they are located in the same group. There are a few more names we use often when discussing where to find elements on the periodic table. The main group elements are those found in groups 1, 2, and 13 through 18, are the more common elements, and have more predictable chemistry. The transition elements are those found in groups 3 through 12 and are metals. The inner transition elements are those typically displaced in the two rows beneath the main periodic table. Elements 58 through 71 are the lanthanoids, and elements 90 through 103 are the actinoids. Based on what we just learned, how would you classify each of these elements? Cesium and indium are main group elements, while uranium is an inner transition element or actinoid. There's one more way we discuss elements in the periodic table. We can classify them as metals, nonmetals, or metalloids. Metals comprise most of the elements and are located on the left side of the periodic table. Metals have specific properties. They are shiny, malleable, ductile, and conductors of heat and electricity. Nonmetals consist of hydrogen plus the elements on the upper right side of the table and are brittle as solids. Metalloids are the elements that border these two larger categories and share properties with both metals and nonmetals. Metalloids always start with boron and stair-step their way down and to the right on the periodic table. Can you classify the following elements as metals or nonmetals? Calcium and nickel are metals, found towards the left of the periodic table, while phosphorus and carbon are nonmetals, found towards the right of the periodic table. All right, now it's time to play the chemistry version of Battleship. Just like the game, we're going to locate elements based on their descriptions, so rather than calling out row and column designations, we'll use periodic table descriptions to find the elements. As you're answering these questions, choose the correct one or two letter symbol for the element. Here are the answers in case you had trouble. As always, I'll leave you with the parting thoughts of the authors.